The point of this video is to give you a bunch of practice in finding grammars for different languages. And some of these languages are going to be regular and some of these languages are not going to be regular. We're moving beyond regular languages just to see what other kinds of grammars we can do. So here's a slide actually from the first lecture on grammars where we were just practicing making grammars, and we're going to just have another quick practice again here just to remind you. If you look at these three languages, you will notice that the first language and the last language are regular languages, but the one in the middle is not regular. It turns out it's context-free. So let's look at this first one. We need to find a grammar for the language a to the n such that n is an element of n, right? That's the same as saying we're finding a grammar for a star, which we've done before. You've probably remember how to do this one, but we're just going to say, well, you're going to start, and either you're going to go to an a followed by the start symbol again, or you'll go to lambda. It's pretty easy, right? Because we just keep kind of building up the a's. This next one, a to the n, b to the n, right? So 0 or more a's and b's, right? So 3 a's, then 3 b's, or 27 a's and 27 b's, or lambda, the empty string, right? As I said a minute ago, no, it's not a regular language, so we can't come up with a regular grammar for it, but we can, of course, come up with a context-free grammar for this language. So let's do that. So when you're doing something like this, a to the n, b to the n, you need to kind of think about how you build it up. The important thing is every time you add a as a non-terminal, you have to add b as a non-terminal. And what we can't do is we can't do something like this. We can't say S goes to ABS as a production rule, because then we could get something like S goes to ABS, goes to AB, ABS, which would mix up the order of our A's and B's, right? And here it's all the A's come first, then all the B's, right? A to the n, B to the n. So that's no good, right? So we can't do that. So let's get rid of that and try again. Okay. So what we're going to do is we need to have the same number of A's and B's, but we need them to kind of bubble out from the middle, right? So our rule is going to look something like this. We're going to say S goes to ASB, right? So every time we put that S in, the A's are on the left and the B's are on the right, or lambda. And if you look at that, then if I'm trying to derive a string like AABB, you'll see what we get is we get something like S goes to ASB, goes to AASBB, goes to AA lambda BB. And we got it. So that's pretty good. Okay. Finally, let's do this last one. Now we want AB to the n, right? The language AB to the n, and that is in fact a regular language, right? So it's just a bunch of ABs, 0 or more ABs. And that was in fact what I wrote in red before, right? So we're going to say S goes to ABS or lambda, right? So every time we put in our letters, we'll put in our ABs, and then we could expand some more if we wanted. I think what you need to kind of really look at and really note here is the difference between how these three grammars work, right? So this first one is just a single letter building it up. It's pretty easy, and in fact, you know, you might want to note that we could also have had said this goes S goes to SA or lambda, right? Nothing wrong with that. And similarly for this last one, we could have said S goes to SAB or lambda. That would have been fine. But this middle one, where we really need to kind of build it up from the middle. It's almost like I keep thinking of it bubbling out of the middle. It's really important that we get that S in the middle. We're expanding from the middle. With that first and last grammar, we can mess around with it to make it regular. But there's no way to get that bubble effect from a regular language, a regular grammar. So here's some problems from the book. Some of these grammars are going to represent regular languages, right? Like this first one, this second one is regular, that's regular, right? So is this one. And others represent languages that are not regular. These are going to be languages that are context free, but not regular. So what I'm going to do is I'm going to start out by doing some of the simpler ones. And remember that now we're just asked to find a grammar, not find a regular grammar, right? So we can find a grammar for a regular language that's not a regular grammar, right? If we put, say, two non-terminals on the right-hand side of a single production rule. So we're going to find grammars for each of these languages. We don't have to find regular grammars, even though some of these languages are regular. And then we'll go into some of the more, we'll look at a couple of the languages that are not regular and see how you can do those. Sometimes it's easier to find a grammar that's not regular for a regular language than it is even to find a regular grammar for that language. So, for example, if we look at this first language here, the language is definitely regular, and given your practice so far, you probably would say, okay, well, here's a grammar for that that's a regular grammar. And there's nothing wrong with this grammar. It is a regular grammar, of course, because it's regular. It is also context-free, as I told you earlier. But here's another grammar for this regular language, and even though the language is regular, this second grammar is not a regular grammar, right? So it's a context-free grammar that happens to represent a regular language. All right. This next one, why don't we underline it in green? We'll do this one in green. B, A to the N, B. So it starts and ends with a B, and then it's got 0 more A's in the middle, right? So another way to write this, if we were just writing it as a regular expression, would be B, A star B, right? So what I'm going to do here is I'm going to get rid of the part that that we don't, that kind of stays the same early on. I'm going to say S goes to B, A, B. And then A is going to go to AA or lambda. And that way we get the B at the front and the end right away. And then we stuff in as many A's into the middle as we want. Okay? Now, again, really important to note, even though this language is regular, right? The language itself, that set is a regular set of strings. This grammar is not regular, right? For sure, because we've got that non-terminal in between the two terminals. Now, of course, here's another way we could write it, which is a regular grammar. So what you need to remember is if you have a regular language, you can write a regular grammar for it for sure, but you can also write grammars that may not be regular. Now this third language is not a regular language. It's got the A to the N, C to the N thing going there, so we need to have the same number of A's and C's. It's not a regular language, so we cannot make a regular grammar for it, but we can do a context-free grammar. So this is going to be something like this. S goes to ASB, or, oops, sorry, S goes to ASC, or stick a B in the middle. All right? Let's do this next one here. A to the 2N, N is an N. So it's we have to always add pairs of A's. We can have 0 A's, 2 A's, 4 A's, and so on. So this is actually the regular expression AA star, right? And again, relatively straightforward. There's no bubbling here. It's, well, or it's bubbling from either side. S can go to two A's and an S, or lambda. Again, I'm doing these pretty quickly. I don't expect that you can do these this quickly yet. I just expect that if you kind of follow along with me, you will, and then do a bunch of these, and also just go and do these on your own, make up your own problems. You'll be good. Now, just as a reminder, this is a regular language, and I happen to have a regular grammar for it. I could also have come up with a grammar that wasn't regular, like this one. It's still a grammar for this regular language. It's just that the grammar itself is not regular. Let's take a look at this one real quick. Notice that it is a regular language, right? This one is A star, B, C star. And that's in contrast to the other one where we had to bubble it out, right? It wasn't a regular language, but this one is a regular language, so we should be able to have a regular grammar for it. And here's an example of a regular grammar for this, but we could also, of course, probably a little bit easier, more easily come up with a context-free grammar for this, a grammar that's not regular, but that is super easy to come up with using your wits. So unless I say give me a regular grammar, you can give me any old kind of grammar you want, but if I do say give me a regular grammar, then you have to give me a regular one. Real quick, this one, if you look, because of the greater than 0 on the exponent for the b, this turns out to be the regular expression A, B, B star, right? And that's super easy to do. And here's a couple of grammars for it. One is regular, one is not. Okay, so the only one here that remains that I want to do is this odd palindromes one. And you need to know what a palindrome is. And a palindrome is, of course, a string that the beginning and end repeat. So here's some odd palindromes. I'll do them in purple over ABC. So you have to have A's at the beginning, B at the beginning and another B maybe, and then we'll put an A in the middle, right? So it reads the same way if you read it forward or you read it backwards. Or C, 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 C is also an odd palindrome, right? And the odd just refers to the number of letters, right? So whether you read it this way or this way, it's the same. And this is another case of bubbling out, right? Whenever you put a C at the beginning, you have to kind of put a C at the end. So for this one, I'm going to say something like, we're going to start by bubbling out the letters. So we could bubble out an A on either side, or we could bubble out a B on either side, or we could bubble out a C on either side, right? And I can't actually fit, I would do some more ors here, but I can't fit on this line, so I'm just going to start another line, but this is the same kind of thing. And once we've done a bunch of bubbling, we can put in the middle an A or a B or a C. So what I want you to try and do is take these two palindromes and make up a few more and confirm that what I've written here actually works. And if you derive a few of these, I think you'll see how this works, and it'll give you a better feel for this bubbling out that I'm talking about. Let's go through an example where we create a grammar for this language that I've got up here above. It's just messy. It's not a regular language, but we have, we have A to the N, B to the N, C to something different, C to the M, D, E, we got F to the Q, D, D, G to the Q plus 3, blah, 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 right? And the idea is that all of these exponents are in the natural numbers. So here you go. I've written this a little bit smaller so that I can edit it a little bit more easily. As I've said, what you really need to do is to think about which of these pieces are stuck together? Which of these pieces do you need to think of together? So for example, the first two symbols here, the A to the N and B to the N, these guys have to work with each other. It's in some level, right? They are sort of partnered because they both need the same exponent. So I'm just going to mark them like that. If you look at the next one, C to the M, that's kind of on its own. There's nothing else with an exponent that has the letter M, right? Here's an F to the Q and the G to the Q plus 3. So those ones sort of need to be together. What other exponents do we have here? We have, there's an R here and an R there, so this whole Fs to the R all the way up to that T to the R goes together. And in fact, inside of that, you can also see there's some X's in here, right? So we've got the T to the X, S, T to the X business going on, right? So what you need to do first, in my opinion, the first step with this is split your language so that you have all of the pieces that are related together and everything else separate. So let me show you what I mean. I'll kind of split down there. And we'll split down there because this A to the N, B to the N, that's stuck together. The C to the M, that is an exponent kind of on its own. Next there's this D, E, which is sort of on its own before this big long piece, so let's split that. There's the giant long F to the Q, all this good stuff. So I'll split after that. E is sort of on its own, so we'll let it be on its own. And this last one, we can't really deal with the inner one until we've dealt with the outer piece. So I'll just split after that outer piece is done, and then we have DE, which is a couple of terminals, right? Just a couple of symbols. So what I'm going to do is I'm just going to label these pieces for my own use. I'm going to call that one a capital A, that capital B, that capital C, capital D, capital E, this whole thing is capital F, and this piece is capital G. So when I write my grammar, I'm going to just do each of these pieces. What I'll say is I'll say that we're going to start by going to A, B, C, D, E, F, G, right? And now all I need to do is tell you how to find the grammar for each of these, and I've sort of concatenated them together here, right? And then we will have a grammar for this whole mess. So let's just get started. We want to start with A. Why not? We'll do them in order. So let's see, what does A go to? Well, we've got our standard A to the N, B to the N thing here, right? Not regular, that's for sure. But we can still write it as a grammar, just not a regular grammar. And so what I'm going to do is we're going to build it from the middle outward, as we always do, and we'll say that goes to A, little a, big A, and then a little b. So we can either keep adding every time we follow this rule, we'll add an A at the front and a B at the end, so it'll kind of grow and grow and grow. Or it can go to just a lambda, right? We're done A. Part B is C to the M, so that's pretty straightforward. So we're just going to say B goes to, well, as many C's as we want, right? So CB or a lambda. Part C is even better, right? C is just two symbols, two terminals. So C just goes to little d, little e. Notice, by the way, I've been a little bit sloppy here. That's a lowercase c and that's an uppercase c, just to make sure it's clear. Alright, what do we do for D? Well, D is an interesting one. We have to build up the outside here, so we have 3 more G's than we do F's, right? So I'm going to do that in 2 steps. I'm going to say, well, what D is going to do is D is going to go to something else. Let's call it H with 3 G's on the end. Because if I do that, then what I've done is I've changed this piece from F to the Q, D, D, G to the Q plus 3. I can just ignore that plus 3 now, right? Because I've already put the 3 G's on the end. And now I'll just have H be that little piece without the plus 3, right? So let's do H. I wonder if I'm going to have enough room on this page. H is going to go to, well, we got to build it up from the middle again. It's going to go to an F followed by an H followed by a G, right? Or, well, we don't have to end with lambda this time. In fact, what we can do is we can just say, well, what goes in the middle of this one? Well, in the middle of this one, we've got just 2 D's, right? So we can say it goes to FHG or DD. All right? That was H. So let's see, we've got A, B, C. We've done D. So we're up to E. Oh, and E's lovely. Look at E. E is a nice little short one, right? E's just letter E. That's fine. E goes to little e. All right. Next up, we've got this Mongo thing for F. Actually, should we just get G out of the way because it's really cute too? Let's just get G out of the way. G is just going to go to DE. All right. And now let's deal with that big F thing. So what do we got? We have Fs to the R followed by T to the R at the end. And we're calling this F. So I'm going to say, let's see. F is going to go to Fs followed by F followed by, what's at the end? It's a T, right? So we'll do as many of those as we want. Or, and what have we got up to? H is the last letter we used. I don't like using I because it looks a bit, it's hard to tell an I from a 1 or whatever, so let's just make it go to J. Okay. So J is going to represent all of that stuff in the middle. So what does J look like? We've got this T to the X stuff followed by an S. So really, if I were still splitting, I might split it there. So let's say that J, and I knew we were going to run out of space. We'll see. I'll squish this down in a minute. J is going to go to, let's just make J go to T followed by the letter, to K followed by the letter S, right? And so now that we've got our J piece, right, we can go to our K piece. So K is going to go to, well, again, we need a TKT to build it out from the center, or what goes in the middle of that? An S. Miracle of miracles, we actually fit everything in there.